In this example, we're going to take a look at law of cosines. Similar to law of sines, it can be used to find any triangle, but in this case, you have three different equations to pick from based on what you are given in your equation or in your diagram. So the first equation is a squared is equal to b squared plus c squared. So that should look familiar because it's part of Pythagorean theorem. But this time we're minusing 2ab times the cosine of a. You can have b squared is equal to a squared plus c squared minus 2 times ac times the cosine of angle b. And then finally you have c squared is equal to a squared plus b squared minus 2 times AB times the cosine of angle C. Moral of the story is the side that you're solving for is opposite the cosine of that angle. So C squared, its opposite angle would be angle C, and that relationship is true for all of these equations. So if we take a look at number one, we have this angle given to us, and we're solving for the opposite side. Notice that we don't have two angles. That's how I know it's not law of sines. So let me go ahead and write that down. So when you're given one angle, then use law of cosines. Okay? Now this example, because we're giving something on all three sides, is an example of side, side, side from when you learned last year. So we would have x squared is equal to 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of that angle 65. And honestly, you just type all of that in your calculator in one go. I'll kind of break it down, make it more manageable. So you have 49 plus 144 minus 168 times the cosine of 65. One thing I do want to note is this last piece right here is actually one value. So it'd be the negative 2 AB times cosine of 65 should be one term. And then finally, if we combine all of those values together, right over here, you'd have 193 minus 168 times the cosine of 65. And then finally, to keep it as an exact value, we can do the square root to get x by itself of both sides. So you'd have x is equal to 11. So that side length is 11 to the nearest 10th. In the second example, notice how we have the angle that we're solving for. So that means we'd have 7 squared, because it is opposite the angle, is equal to 11 squared plus 12 squared minus 2 times 11 times 12 times cosine of x. Okay, simplify. 49 is equal to 121 plus 144 minus 264 times the cosine of x. Now just a reminder, when we're solving for angles, this is where you have to use inverse. So we're going to have to eventually get the cosine of x by itself. So we simplify values again. We get 265 minus 264 times the cosine of x. We subtract the 265 to get negative 216 is equal to negative 264 times the cosine of x. And then finally, we have to divide by the negative 264 on both sides. So you'd be left with 0.8 0.8182 is equal to the cosine of x. So we would have the inverse cosine of x is equal to 0.8182. And when you hit the inverse button, your angle for x would be to the nearest tenth, 35.1 degrees. Okay. I'm going to write that down one more time. So use inverse to find angles. That's kind of the big idea between the first step solving for, or the first example solving for sides, second example solving for angles.